You are looking at the most expensive mistake in the history of the U.S. Navy. Although it appears as small as a fishing boat on radar, its cost is absolutely mind-boggling. We will be talking about all of this in just a moment. And believe me, it is absolutely insane because the Pentagon was on the very verge of scrapping this project entirely. That is, until the covert decision that would transform it into the ocean's most lethal, hypersonic monster. The birth of the Zumwalt class was a direct result of America's shifting naval doctrine after the Cold War. The era of hunting Soviet submarines in the open ocean was over. The new targets were coastal waters. The objective was clear: to provide heavy artillery support to ground forces from the sea, penetrate enemy air defense networks undetected, and eliminate strategic targets inland. The Zumwalt was engineered precisely for this offensive and deterrent role. But there was a problem, folks, and a massive one at that. The project soon spiraled into one of the greatest cost crises in military history. Initially, the U.S. Navy planned to order a staggering 32 of these ships. Yes, they planned to, but the problem they encountered turned everything upside down. The design was so complex and the R&D processes so expensive that as the budget per ship spiraled out of control, the project was slashed from 32 ships to just 3. Now, let us take a closer look at the technical specifications and raw data of this massive structure, my friends. The USS Zumwalt spans a massive 190 meters in length and 24.6 meters in width. Its draft sits at exactly 8.4 meters. With these dimensions, it is nearly twice the size of an Arleigh Burke-class destroyer, the current backbone of the U.S. Navy. Its fully loaded displacement is a staggering 16,000 tons. But how does a mass this colossal manage to remain completely invisible on radar? The answer lies within the vessel's extraordinary architecture. Unlike traditional ships, the Zumwalt features an inverted hull, known as a tumble-home design. This means, as you move upward from the waterline, the hull narrows inward rather than flaring outward. Furthermore, the entire superstructure is constructed from specialized carbon composite materials, designed to absorb radar waves and reinforced with hidden layers of balsa wood. You will not find a single antenna, protruding mast, or vertical post on this ship. Every radar panel and sensor is integrated into the pyramid-shaped superstructure. Thanks to this brilliant engineering, when this 16,000-ton steel monster is hit by enemy radar, it appears as nothing more than a 15-meter wooden fishing boat. What drives the Zumwalt is not a traditional mechanical shaft, but a massive electrical power plant. At the heart of the ship lie 2 Rolls-Royce MT-30 gas turbines and 2 auxiliary diesel generators. This system generates a staggering 78 megawatts of electrical energy. To put that into perspective, this power is enough to meet the entire electrical needs of a small city, completely on its own. Yes, it is a bit insane. This massive energy generated is routed directly to advanced electric motors, completely eliminating mechanical losses. This pushes the vessel to speeds exceeding 30 knots, or 56 kilometers per hour. Furthermore, this electrical infrastructure also powers the AN/SPY 3 multifunction radar system, the primary brain of the ship. Operating in the X-band, this active phased array radar is capable of simultaneously detecting and tracking over-the-horizon targets, low-flying cruise missiles, and coastal threats. The greatest design tragedy of the Zumwalt class and the massive evolution that followed intersect right at this very point. The ship was equipped with 2 155mm advanced gun systems known as AGS, specifically designed for shore bombardment. For these guns, specialized rocket-assisted munitions called LRLAP, with a range of 150 kilometers, were developed. However, when the fleet size was slashed from 32 to just 3, mass production of these munitions became economically impossible. The cost of a single artillery shell neared $1 million. This was virtually identical to the price of a Tomahawk cruise missile. The Pentagon shut down the system entirely. The guns remained completely useless. But nothing was over just yet, my friends, because right at this point, the modernization phase kicked in. The Navy began completely dismantling these useless, massive gun turrets, integrating in their place the APM, or Advanced Payload Modules. Placing the Mk-57 cells along the outer hull, rather than the ship's center, provides an unmatched survivability advantage. If one of these cells is struck, the blast energy is directed outward, safely away from the ship's core, preventing catastrophic internal damage. But is this steel, which narrowly escaped the scrap heap at the last second, to be transformed into a technological marvel, truly flawless? Absolutely not. Real-world operational feedback revealed severe design flaws. The first issue lies within the complex cyber infrastructure of the Command and Control Center. The ship is managed entirely by software, a reality that leaves it highly vulnerable to potential cyber attacks. Secondly, the issue of countermeasure vulnerability. The tumble-home hull design can create severe stability problems in rough seas. This unconventional bow structure brings a dangerous risk of the ship losing its balance under extreme stormy ocean conditions. The total cost of the project, including R&D, reached $22 billion. No joke, my friends. With this budget, nearly 2 nuclear aircraft carriers could have been built. In conclusion, my friends, engineering errors, allegations of a multi-billion-dollar fiasco, and ultimately, a destiny transformed into the pioneer of the hypersonic era. Yes, my dear friends, thank you for patiently examining and analyzing the data with me. See you in the next military technology analysis. Stay tuned.